Hello students, welcome to the channel. In this video, we solve the fourth and final passage of the reading section of the form Z04, the special testing form of ACT April 2021. This passage is adapted from Summer World, A Season of Bounty by Bernd Heinrich. Adaptations of plants to deserts include dormancy and a variety of structural and behavioral adaptations. The majority of desert plants depend on a strategy that capitalizes on small size. They are annuals that spring up from dry, dormant, heat-resistant seeds. Some of these seeds may wait up to half a century before they are activated. The plant's challenge is to be quick enough to respond to rain so that they can produce their seeds before the earth dries up again, while not jumping the gun to start growth until there is sufficient water for them to grow to maturity for seed production. Some achieve this balance on a tightrope by measuring rainfall. They have chemicals in their seeds that inhibit germination, and a minimum amount of rain is required before these are leached out. Others have seed coats that must be mechanically scarred to permit sufficient wetting for germination, and the scarring happens only when they are subjected to flash floods in the riverbeds where they grow. A plant in the Negev desert releases its seed from a tough capsule only under the influence of water through a mechanism that resembles a Roman ballistic machine. Its two outer sepals generate sideways tension that can fling two seeds out of the fruit, but the two seeds are held inside by a lock mechanism at the top. However, when the sepals are sufficiently wetted, then the tension increases to such an extent that the lock mechanism snaps and the capsule explodes and releases the seeds. Okay, so this is an interesting paragraph and talks about how plants in the desert survive and thrive, right? And this is important because there is very little water in the desert. So plants need to make sure that they germinate at the right time when there is water availability so that the seeds can, have enough water to grow. At the same time, they need to preserve water, right? And they cannot grow to maturity unless enough water is available. Now, this paragraph describes three mechanisms by which the germination will not happen unless enough water is present. So if you're doing this under a test, you should make sure to annotate those three mechanisms. So the first is they have chemicals in their seeds that inhibit germination, and a minimum amount of rain is required, right? So there are chemicals that inhibit. Others have seed coats that must be mechanically scarred, and that scarring can only happen with flash floods. And then there is this third example, which is a very specific example of a plant that uses what is the mechanism? A lock mechanism that can only be that can only come into play when there is enough water, right? So make sure that you annotate these. In moist regions where it rains predictably, though not necessarily in abundance, we help agricultural plants to capture the precipitation by scarring the soil to facilitate the infiltration of the water into it and hence into the roots. Least runoff and maximum water absorption are achieved by plowing the soil. However, such a strategy would not work in a true desert such as the Negev. A different program is required there because rain is infrequent and plowing would facilitate only the evaporation of scarce water from the soil. The solution applied by the people who inhabited the Negev in past centuries was a practice they called runoff farming. Farmers had mastered harnessing the flash floods that rushed down into the gullies by catching the runoffs, not only by making terraces, but also by building large cisterns into which the water was directed to be held for later use. Remnants of these constructions still exist. Okay, so this paragraph brings out a chief difference between regular farming and farming in a desert. In regular farming, when we know that the water supply is predictable, plowing can help that water reach the roots, right? But in a desert where water supply is intermittent and not predictable at all, plowing can actually expose the water under the surface to the elements, and it can actually lead to greater loss of water. So in this case, a different program is required, and what the Negev peoples did in the past was something called runoff farming, which was harnessing the flash floods to catch the runoff, and constructing large cisterns, some of which, the remnants of some of which exist to this day. Water storage mechanisms have been invented by other organisms living in deserts, but mainly through modifications of body plan. Many plants, especially cacti and euphorbia, have the ability to swell their roots or stems with water stores. Possibly the most familiar is the saguaro cactus, the Carnegie gigantea of the Sonoran Desert in the American Southwest. It has a shallow root system that extends in all directions to distances of about its height, 50 feet. In one rainstorm, the root system can soak up to 200 gallons of water, which are transferred into its tall trunk. This trunk is pleated like an accordion and can swell to store tons of water that can last the plant for a year. The cactus has no leaves, but the stem is green and can photosynthesize and produce nutrients as well as store water. The saguaro's survival strategy requires it to grow extremely slowly, but it lives a century or more. Okay, so here we speak about plant adaptations, right, that can help preserve water in the desert. And we focus particularly on the saguaro cactus, which has a shallow but a widely dispersed root system that can soak up to 200 gallons of water. And all of that water can then be stored into the stem, right, which can swell and store tons of water. There are no leaves, but the stem itself is green and carries out photosynthesis. Some desert animals similarly store water. The frog Cyclorana platycephala from the northern Australian desert fills up and greatly expands its urinary bladder to use as a water bag before burying itself in the soil, where it spends most of the year waiting for the next rain. While in the ground, it slows off skin and forms around itself a nearly waterproof cocoon that resembles a plastic bag and reduces evaporative water loss. Desert ants of a variety of species of at least 7 different genera in American as well as Australian deserts, collectively called honeypot ants, have evolved a solution that combines water storage with energy storage. Ants typically feed each other, and some of the larger worker ants may take up more liquid than the others, and others may bring more. Those that take the fluid may gorge themselves until they distend their abdomens up to the size of a grape, by which time they are unable to move from the spot. They then hang in groups of dozens to hundreds from the ceiling of a chamber in the ant nest, where they are then the specialized so-called repletes that later regurgitate fluid when the colony members are no longer bringing the fluid in, but rather needing it. Okay, so these last two paragraphs talk about animal adaptations. The frog adaptation, I think, is quite straightforward. But in the case of ants, there are these groups of worker ants that fill themselves up with water, and they become the size of a grape, right? And then they kind of provide that extra water when the other worker ants are unable to procure any. So this passage is primarily about surviving in the desert and looks at it from the perspective of seeds, of plants, germination, looks at it from the perspective of human habitation, from the perspective of plant growth and animal adaptation. The fourth paragraph marks a shift in the focus of the passage from 63 to 71. Yeah, so now we are shifting to animal adaptation, right? Plants that store water above ground to plants that store water below ground. Animals that don't go dormant to animals that do go dormant. Desert-dwelling plants to desert-dwelling animals. Inhabitants of the Negev desert to inhabitants of the northern. So it's C, right? We are moving from a discussion of plants to animals. Based on the passage, the author's use of the word measuring most nearly describes the way that some desert plants, line 12, by measuring rainfall. So measuring rainfall here refers to how these plants kind of get a sense of how much water there is with their unique adaptations, right? For example, there could be chemicals that only get leached when there is enough water. There could be seed coats that are only scarred when there are flash floods, right? So measuring here refers to that some desert plants have roots that are extremely sensitive to moisture levels in the soil, have methods of delaying seed germination until a certain amount of water is present, are visibly more vigorous after a rainfall, can calculate how many inches of rain have fallen in recent days. So it's G, right? They have methods of delaying seed germination. J is not correct because that's a very exact option that is not supported by the passage, and it also gives plants, a sort of agency and intelligence that the passage doesn't support. 33, which of the following statements best summarizes the process by which Cyclorana placitifera survives in the desert? The frog stores water in its body, buries itself, and conserves water until emerging at the next rain. The frog buries itself, waits for rain, absorbs rainwater through its skin, and emerges. The frog forms a nearly waterproof cocoon around itself, buries itself, and waits to emerge until it needs water. The frog buries itself, absorbs water through its skin, and goes dormant until springtime. So it's A, right? We know that the frog, it fills up its urinary bladder and then buries itself, where it spends the year waiting for the next rain. Okay. Based on the passage, which of the following plants and animals employ a communal strategy to survive in the desert? So the ants, right, for sure, they definitely apply a communal strategy. They work together. The cactus, no, the cactus works alone, right? So there is no mention of the cactus applying. And the frog also works alone, right? So it's just the honeypot ants. The passage most strongly suggests that compared to the frog, the honeypot ants are unique in that they can store water inside their bodies, live in Australian deserts, combine water storage with energy storage, go dormant during dry times. So it's C, right? They combine water storage with energy storage because they have evolved a solution that combines both water and energy storage, right? Because when they're kind of storing energy by making sure that those huge, worker ants that they take the fluid and they gorge themselves, and they're not able to move from the spot. So they are kind of conserving energy as well as water, right? So that's a strategy that makes them unique. Okay. Which of the following provides the best paraphrase of lines 7 to 11? What is that saying? I'm reading from here, right? Yeah. The plant's challenge is to be quick enough to respond to rain so that they can produce their seeds before the earth dries up again, while not jumping the gun to start growth until there is sufficient water from them to grow to maturity. Okay, so annual plants survive in deserts by making seeds swiftly when conditions are right. Annual plants in deserts make seeds during dry conditions, so the seeds will be ready when rain arrives. Dry conditions require the seeds of desert plants to start germination prior to the arrival of rain. The seeds of annual plants in deserts are designed to wait years for the right conditions for growth. Okay, so I think it is, yeah, so they may have to wait before they are activated, right? It's also given in the previous paragraph. Because so if you look at the options, yeah, I would prefer J. I'm just going to try and eliminate F, G, and H. Annual plants by making seeds swiftly. No, it's not. They don't make seeds swiftly. In fact, their seeds have to wait for up to half a century. It's not about making seeds during dry condition. No, it's not about prior to the arrival of rain. Yeah, so it's J. Based on the passage, it can most reasonably be inferred that the scarring some seeds require before germination is accomplished through intense drying experience between rainfalls, internal tension from the seed's capsule sepals, chemicals in the seeds, abrasion sustained during flash floods. So that's here, right? It's the second part, right? Others have seed cores that must be mechanically scarred, and the scarring happens only when they are subjected to flash floods. So this second point is the answer for question 37, option D. As used in line 26, the word extent most nearly means. However, when the sepals are sufficiently wetted, then the tension increases to such an extent, to such a level that the lock mechanism snaps. To such a degree, right? We're talking about a level, extent, degree. It's not about length or boundary or reach. According to the passage, which of the following actions did people in the Negev desert take in order to farm there? No, they didn't plow the soil because widening gullies, constructing terraces, constructed aqueducts. They constructed terraces, right? It's given very clearly here. They constructed terraces, but they also built cisterns. So it's C. Based on the passage, the pleats in the body of the saguaro cactus increase the efficiency of photosynthesis, allow the cactus to expand for storing water, reduce evaporative water loss, regulate the cactus's growth. So it's G, right? Because it's given here that they have, the trunk is pleated, right? Like an accordion, and can swell to store tons of water. So those pleats can adjust and grow to store water. Okay, so that was the last reading passage. Let's grade it. 31 to 40. 1 second. CGAJC, CGAJC, 36, FDGCG. 36 is F. Okay. 36 is F, so we got this wrong. DGCG. DGCG. Okay. I actually cancelled F. Annual plants survive in deserts by making seeds swiftly when conditions are right. Okay, I don't think that 30. Let me confirm. Reading Z04, 36 is F. Okay, let me read that again then. Adaptations of plants to deserts include dormancy and a variety of structural and behavior adaptations. The majority of desert plants capitalize on small size. They are annuals that spring up from dry, dormant, heat-resistant seeds. Some of these seeds may wait up to half a century before they are activated. Oh, right. Okay, the plant's challenge is to be quick enough to respond to rain so that they can produce their seeds before the earth dries up again. Okay, so the seeds are not, they're not even produced. Okay, I did not understand the word activated correctly. Okay, the seeds are not even produced, right? They do not wait because the seeds are not activated, right? Remember this line that the seeds may have to wait up to half a century before they are activated. The plant's challenge is to be quick enough to respond to rain so that they can produce the seeds. So only when there is rain, they make seeds swiftly when the conditions are right. Yeah, so indeed F is correct. Okay, so that was the final passage of the reading section. And with that, we've completed solutions to the reading section as well. I will put a link in the description box to the playlist, solutions playlist, which now has solutions for English, math, and reading. The science solutions are left, which I'll upload soon. So make sure you subscribe in order to receive a notification when science is uploaded. I'll see you guys soon. Take care. Bye-bye.